Ever stared at a line of code and wondered how the computer actually starts to understand it? It's not magic, not at all. It's a really fundamental process in computer science. So today, let's dive into the very first step of that journey, lexical analysis.
Okay, so we've all seen a line of code like this, right? To you and me, it's a super simple command to print hello world. Seems totally obvious. But to a computer, it's something else entirely.
You see, to the machine, that familiar line is just a long, meaningless jumble of individual characters. print, an open parentheses, a quote, you get the idea. So how in the world does it go from that mess of symbols to an instruction it can actually follow? That's the big question we're going to answer right now.
Well, the process is actually pretty intuitive. The computer starts by doing the exact same thing we do when we read a sentence. It groups all those characters together into meaningful chunks, or, well, words. And that, right there, is the heart of lexical analysis.
So let's follow that journey. How do we get from a raw stream of characters to something that has actual structure and, a chance at being meaningful?
The first key term we got to know is lexeme. Now that sounds fancy, but a lexeme is just a sequence of characters from the code that clumps together. The easiest way to think about it? It's just a word. In our Hello World example, printf is a lexeme, and so is the text inside the quotes. Simple as that.
All right, so what's next? The token. If a lexeme is the word, then the token is its part of speech. It's the category that the word belongs to. Is it a keyword, an identifier, an operator? The token tells us what kind of word the lexeme is.
In this table here, it connects those two ideas perfectly. You can see the actual text, the lexemes, like if or pi, are scanned, and then they get classified into a token type. So the word if becomes a keyword token. The word pi becomes an ID or identifier token. This is that fundamental step of categorizing all the words in our code.
So who's doing all this work? Well, this brings us to the hero of our story, the lexical analyzer, which a lot of people just call the scanner.
The scanner is basically the front door for the entire compiler. It is the very first thing to get its hands on the raw code you wrote, and its job is to get everything ready for all the steps that come after. Let's zoom in on how it works. See, the scanner has a partner, the next phase, which is called the parser. The parser is constantly saying, hey, get me the next token. The analyzer then scans the code, finds the next logical word, figures out what type it is, and then hands that token back to the parser. And this just happens again and again, over and over, until the whole file is read. So yeah, its job really boils down to these key tasks. It reads the characters, groups them into lexemes, spits out the matching tokens, and, this part is super important, it cleans things up. It gets rid of all the comments and the extra white space. The stuff that's helpful for us humans, but it's just noise to the rest of the compiler. Here's a perfect, really simple example. The statement x equals y plus 10 gets scanned and turned into a stream of 5 separate tokens. You've got an identifier for x, an assignment operator for the equal sign, another identifier for y, an addition operator, and finally the number 10. What was once just a flat string of text is now a structured sequence.
So how does it know that 10 is a number and x is an identifier? Well, it uses a super powerful pattern matching tool called regular expressions. Just think of these as a set of rules or templates. There's a rule that says a number is one or more digits, and another that says an identifier starts with a letter. The scanner uses these rules to categorize every single lexeme it finds.
Now you might be thinking this is all very specific to building programming languages, right? But the places where lexical analysis is used, it's surprisingly broad.
So seriously, why should we care about this process if we're not planning on writing the next great programming language?
Because it's literally everywhere. Ever wonder how your code editor knows to color keywords and variables differently for syntax highlighting? That's a lexical analyzer working in real time. When a search engine like Google scans a web page, it first uses this process to break the text down into words, into tokens. It's even a huge first step in natural language processing, which is how we help computers begin to understand human language.
And to really get it, it helps to know what it isn't. Lexical analysis is all about one question. What are the words? The very next step, syntax analysis, asks a different question. Does the sentence make sense? So one finds the words, the other checks the sentence structure. This quote really just nails its role perfectly. It's that critical prep step, that formatting, that makes everything else that follows even possible. Without it, the rest of the compiler would just be staring at a meaningless wall of text.
So if there's one thing to take away from all this, it's this.
Lexical analysis is the bridge from chaos to order. It takes a raw, meaningless string of characters and transforms it into a structured, categorized sequence of tokens that a computer can finally start to work with.
And of course, that leads to the next big question. Okay, now that we have all these perfectly categorized words, these tokens, how does the computer figure out if they're arranged in a valid sentence that actually follows the rules of the programming language?
Well, that is the job of the parser. But that's a story for another explainer.